to get started? All right, so you guys, this is section 1 of scientific notation. We're actually going to have 3 days of it. I'm going to have 2 days of learning. So today we're going to just kind of get our feet wet, kind of figure out what scientific notation is. Monday, we're going to do some operations with scientific notation. And then Tuesday is going to be a big packet that kind of takes all of that stuff and practices it all together, okay? So kind of review. All right, so what is scientific notation and what is it used for? All right, here's our objectives for the day. We're going to write numbers in scientific and standard notation, and we're going to use that scientific notation. Okay, so there's 2 different ways to write numbers. There's something called standard notation, and this is what you guys have used forever and ever and ever, okay? So we have standard notation, would just be a regular old number. So let's say we have, let's say we have 2,347,100. Okay, so that's standard notation. What if that was money in my bank account? That would be good, wouldn't it? All right, now that's standard notation. Scientific notation says, wait, that's a kind of a big number, and I want to make a shorter way to write that really large number. If you think about it in science, they have to deal with a lot of very, very, very large numbers and a lot of very, very, very small numbers. So think about a very large number might be the number of miles it is from the Earth to Jupiter. Okay, that's a very large number. A very small number might be the weight of an atom. Okay, so really, 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 really small. So what they came up with is this standard way of writing very large, very small numbers so that everybody could understand the shorthand, the short way to talk about these numbers. Okay. So the standard notation for this money in my bank, trust me, I don't have $2 million in my bank, is 2,347,100. This is what you're used to. That same number written in scientific notation, what we do is the invisible decimal is way at the end, right? If there's not a decimal in it, it's at the end. What we do is we move that decimal so that the number itself is between 1 and 10. So we're going to talk about this number as being 2.3471. Okay, so that's my number, 2.3471, but that's not the same thing, right? $2,347,100 in my bank account is not equivalent to $2.3471, right? What we do is we multiply it by a power of 10. So what power of 10 would I have to multiply 2.3471 by in order to make it equivalent to 2,347,100? Does anybody know? How many times I'd have to multiply this number by 10?
6.
Yeah, how do you know? How'd you know that?
There's 6 numbers behind 2.
There's 6 numbers behind 2. That's how far I had to move my decimal, right? I moved it 1, 2, 3, 4, 5, 6. I had to move it 6 places right here. So that's how many 10s I had to multiply it by. Okay. This is really good stuff once you get going on it. Okay. Let's see. I need to look at, oh yeah, Maddie, you had it too. All right. So you guys, this is the actual rule itself. Scientific notation is a number written as the product of 2 factors in the form a times 10 to the nth. where n is between 1 and 10. Okay, so that is our number. It has to be between 1 and 10. And then we multiply it by a power of 10. Okay, so here we have 3.4 times 10 to the 6th. So if we multiplied this out, we would get 3,400,000. So that's a standard equivalent. If we had 5.43 times 10 to the 13th, that means I have to move that decimal place 13 units. So that's 543, and then I think 11 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, now this is looking more like the national debt. All right, does that make sense? This one has a negative exponent, 2.1 times 10 to the negative 10th. So instead of multiplying it and getting it a very, very big number, remember that negative exponents are really repeated division. So instead of multiplying by 10 times, we're going to divide, which means we're making it smaller. So we're going to move it to the left 10 times. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you fill in all these guys with zeros. All right, so that is what this is all about today, is being able to convert back and forth between standard notation and scientific notation, and being able to recognize it if it's really in scientific notation. Okay, so to be in scientific notation, you have to have a number out front times a power of 10, right? This number right here has to be between 1 and 10. If it's, all right, let's take a look at this guy. Example 1, is each number written in scientific notation? Remember, it has to have those two parts. The first number has to be between 1 and 10. Is 56.29 between 1 and 10? Right, Maddie? Is 56.29 between 1 and 10?
No.
No, why not? Okay, you guys,
56.
this is a game of Goldilocks and the Three Bears. Okay? How many of you know Goldilocks and the Three Bears, right? Our first number has to be between 1 and 10. If it's below 1, it's too small. If it's bigger than 10, it's too big. If it's between 1 and 10, it's just right. Okay, so that's our game. So 56.29 is too big. So this would be a big fat no, because it's too big. What about letter B? Garrett, look at 0.84. Is that between 1 and 10? Garrett? Garrett? All right, Sean.
He said no.
He said no, why not? Is it too big, too small, or just right? Okay. Sophie, tell me, what is it?
It's
He
too
said-
small.
It's too small.
Garrett said that.
Garrett said that? Okay. All right, you guys, so far so good. Now let's look at letter C. Look at the first number. Is it between 1 and 10? Yeah, it is. So far this works. So that works out. But what about this guy? Is that the desired power base. No, what is it supposed to be? The base should be 10. So this is no, because the base should be 10. Okay. So now we look at the next one. 52 times 10 to the second. Is that in scientific notation? Addison, you're saying no. Why not?
Because it's not between 1 and 10.
It's not between 1 and 10. It's too big, right? Okay. So that is how we determine whether it's written in scientific notation. Now we actually have to write it in scientific notation. So you guys, we have these numbers that we have to write as a product of a number between 1 and 10 times a power of 10. So there's two parts to this that we have to figure out. We have to figure out what this front number is, which means our decimal has to be in the right spot. Right now, it's 56,900,000. Is that between 1 and 10? No, it's not. So there's an invisible decimal back here, and we have to move it until we get it to the just right spot. Evan, where is the just right spot?
In between the 5 and the 6.
In between the 5 and the 6. So we're going to put 5 point, and then we have to write any non-zero numbers after it. As soon as we hit a 0, we can stop. So we have less to write out. Okay, so we have 5.69. How many times did we move that decimal? Let's see, Cooper, how many times did we move the decimal?
7.
7. Okay, now you guys, here's the hardest part of this. How do we determine if it's a +7 or a -7? Can anybody tell me something that you could use to determine whether it's a positive or a negative?
If the original number is a decimal,
Okay, that would seem like it, but let me tell you this. This is how I always do it. I like to think of money and my bank account. If it's an amount of money that I would be like, yeah, I would like this in my bank account, that would be a positive. Okay. So would I like 56,900,000 in my bank account? Yep. That's a positive exponent. Okay. Now come down here to this one. If this was what my bank account read, would that be a good thing? No, it wouldn't. I wouldn't be able to pay any of my bills with that. Okay, so this is going to have a negative exponent. All right, so here's the thing. If it's too big, if it's bigger than 10, it's going to be a positive. If it's less than 1, it's going to be a negative exponent. Okay. All right, so let's go ahead and do this one. We need to make this so that this is between 1 and 10. Right now, too small. Decimal's here, so I'm going to have to move it. I'm going to have to move it this way in order to get it to be between 1 and 10, right? So 9.85, that's the right location. How many places did I move it, Caitlin?
3.
3, and it is going to be a -3 because that initial number was not something I wanted. I have a really negative attitude about this number in my bank account, right? All right, so you guys, positive or negative? Positive. All right. Let's see, Vincent, where am I going to put that decimal so that my number is between 1 and 10?
In between the 4 and 6.
Absolutely, between the 4 and the 6. So I'm going to write this out as 4.6205. 5. As soon as I hit all zeros, I can stop writing, but I do need to write out those. All right, now it's always times 10. And how many times did Vincent move it? Anna? Seven, that is correct. And that would be a positive 7 because I want 46 million in my bank account. All right, how about letter D? First of all, is it going to be a positive or a negative, Hunter?
Negative.
Negative. All right, good. So that means I'm going to have something times 10 to a negative, whatever that number is. So, all right, let's see. Grady, where should I put my decimal so that that number's between 1 and 10?
Between the 3 and the
Perfect. 3.25. And how many places did that get moved? Braden? One.
Six.
Yep. So we have 3.25 times 10 to the negative 6th. Hey, you guys, so far so good, huh? Is this pretty good? Good stuff? Awesome. All right, but now we got to go back the other way. So now we have scientific notation and we need to change it into standard notation. So I have 1.55 times 10 to the 6th. So this means I'm going to write out my 1.55. And I have to move my decimal. See that? That's a positive number. Which direction am I going to move my decimal in order to give me a positive attitude about my money?
To the right.
To the right. So I'm going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. Now the 2 5s took up 2 of those spots, but these empty loops, what am I going to put in there? Ava, what am I going? Oh, yep, Evan, you got it. Zeros. All right, so that would give me 1,550,000. Okay, so that's because it was a positive exponent. But over here we have a negative exponent. So I'm going to write out 2. Where's the decimal? Ava, where's the decimal in this number? There's not a decimal, so where is it? Ava, are you there? Right, after the 2. Okay, so Kai, you tell me, which way am I going to move my decimal?
To
Yes, sir.
the left.
What was that?
To the left.
To the left. And Jaden, I'm going to move it to the left. How many places?
Six.
Oh, I'm on this one right here. How many places am I going to move it?
11.
11. That's a lot of places. Okay, so here's my decimal. I'm moving it 11 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, that's a lot of empty loops, right? Let's throw in some zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Definitely not something I want in my checkbook, right? All righty. So you guys, that's how you change back and forth between standard and scientific. And then we have one more problem and then you guys can get started on your homework, okay? So we need to not only be able to write in standard from standard to scientific and scientific to standard, but we also need to be able to compare numbers. Okay, so remember when you compare, you're trying to decide less than, greater than, equal to. We want to put these three. Notice these are the parts of an atom, right? Neutron, electron, and proton. Mrs. DeCook would be so proud of us right now. Just saying. We need to order them from least to greatest. Now, normally when we compare numbers, we just look at the number and see which one's less, right? But when they're in scientific notation, you can't just look at this guy out front and say, oh, hey, look, let's see, this one's the smallest. It isn't. You actually have to look at the exponent of the 10. So this has a negative 24. This has a negative 28, and this has a negative 24. So which one's the smallest out of those three numbers?
Electron.
The electron. So the electron would come first because its exponent is the smallest. Okay, so first we have our electron. All right, now you can look at the neutron and the proton. Now they both have negative 24. Since they have the same exponent, now you can go ahead and look at the actual number out front, the number between 1 and 10. And let's see, this one, 1.6726 is less than the neutron. So the proton would come first, or second actually, because it's after the electron. And then we would have the neutron. Does that make sense? Always look at your exponent first. And then go to the number in the front. That's how you're going to compare numbers when they're in scientific notation form. Do you guys have any questions before I let you go and start working on your homework? All right, now, how many of you agree with me? This is kind of fun, especially when you can pretend like you got like all that money in your bank account, right? Pretend like you have that money. Doesn't mean it's going to happen ever, but at least we can pretend. So our homework then is page 402, 1 through 22, and 34 through 39. And this is due on Monday. So you guys, you have a good amount of time right now to get some of this done in class, so you have less homework over the weekend, okay? I will have my 3 o'clock Zoom session today after school if you do have questions for me, all right?